We need to load the tasks out of the database. Let's start with that. So right now, when the application starts, we load all the tasks that the application knows about and display them in the list. And nothing is actually going to change there. We're going to have the same exact behavior. But in this case, we're going to have to deep down in there refactor to get the list or compose a list from the database instead of from by creating a new list, just a blank list to start with, which is what we did before. So let's talk about what the SQLite Open Helper is going to do to help us there. This is a flowchart that talks about what a SQLite Open Helper will do given a couple different states. So when you construct a SQLite Open Helper class, when you create a new class, the arguments that it takes are the file name for the database, so you can have a couple different databases in your application, and it takes a version number. The version number helps the SQLite Open Helper decide if anything has changed about the database and if it needs to be upgraded. So in the case that the file doesn't exist, the SQLite Open Helper will create the database file for you, and then it will call back to a method called onCreate on your instance of the class. And after onCreate is done, then it assumes that the database is ready. And in the case that the file does exist, then it will check the version number, and if the version number has changed since the last time the SQLite Open Helper has looked at the local database, so this will be in the case where you've shipped a new update to your application and the user has downloaded it and runs it for the first time, and then for the first time since the upgrade, and then the SQLite Open Helper opens up, looks at the version number and sees that it's changed, so then it will call out to a helper method called onUpdate, and you can deal with any changes to the structure of the database, any changes that you need to make to existing data to fit that new structure. And then in that case the database will be ready, and then in the most common case probably the file will exist and the version number will not have changed. In that case the SQLite database will be ready as well. And that's what the SQLite Open Helper helps you do, get through a couple of different of those common cases that you have to deal with. So the first steps that we're going to need to take when we create the database is to use a SQL statement that is called a create statement. So let me kind of give you an idea of what that looks like. To create a table with SQL, you use a create statement, and a create statement is just simply create table, table name, and then inside of parentheses, list of columns and their definitions of their types. An example here is this is what we're going to be using in our code. Create table tasks. So this will create a table that we call tasks, and it will have an ID, and it will have a name, it will have a complete, and we'll just store that as text because there's no Boolean in SQLite. We could use an integer with a 0 or a 1 if anybody's familiar with SQL setup, but what I'm actually going to do is store a string and have Java interpret that string for us into a Boolean value. So if any of the people that are not familiar with SQL are also not familiar with the concept of a database, basically think of like an Excel spreadsheet. That's a good place to start, although it's better at doing a lot of things than an Excel spreadsheet would be. But you think of columns and rows, and what we're defining here is a list of columns, which could sort of correspond to attributes on an object, and then each one of the rows in the database are going to be specific instances of the type that the table holds. So in this case, we'll have a table called tasks, and the columns that will store data about for those tasks are an ID, which will uniquely identify each task, and then the name, which will be the name of the task that we display inside the list, and then whether or not it's complete. And then each row will get out of the database and turn into a task object, and that's kind of a common pattern in what's called object relational mapping, which there's a lot of software that takes care of. But in our case, we're just going to hand roll our own little solution where we pull pull data out of the database and put data into the database explicitly based on attributes on objects like the task object. One more bit of information I may need to explain here is what's going on in that ID line. So what you need inside of a database commonly is a way to uniquely identify a particular row compared to other rows in the database. So we have here the most common way of doing that, which is by creating what's called a primary key. And the primary key, the database will manage to make sure that there is no duplicates, so that this is just an ID, some number. It really doesn't matter what it is, but it needs to be unique to each row. So the database is going to make sure, because that's a primary key, that there's never a duplicate put into the database. And then the auto increment there just means that it's going to take care of creating the ID for us and making sure it's not unique in a serial manner. So the first time we insert one, it'll probably end up being 1 for that ID. The next time we insert a task, it'll probably end up being 2. And if we deleted 2, it may be 2 the next time we insert a task, or it may be 3. But in any case, it's up to the database to deal with that, so we don't have to deal with that in our code, which is nice. And then at the end is a little phrase, not null, which makes sure that the database will not allow that ID to ever be null. So this may be new for a lot of people. It was a kind of a long explanation. I don't know is there any questions about creating database tables?
The only question I got related to this was somebody was curious why the complete column was not a Boolean instead of text.
Yeah, so I explained that. There's no Boolean type for SQLite. I could have stored it as an integer and either done a 0 or 1 and then translated that, but I just found it easier to store it as a string and allow Java to get it. There's a method on Boolean, I think, that will interpret a string as a Boolean.
And then the other thing, somebody noted that not null might not strictly be necessary because it might be that by default.
Primary keys are
But that might be something that you just wanted to call out so that we all know that by default it's not null.
Yeah, that's a good point. That may be the case.
Is there an ORM for Android? And I hear there's one on the iPhone.
Yeah, the iPhone has core data. No, there's not anything provided by Google for the iPhone or for the Android framework. And I don't know if something like Hibernate will work, or if there's a light Hibernate or something. That's a good topic for the forum. Okay, cool. All right, now once we've created a table, at some point we will be putting data into the table that we want to get out. And when that's the case, then we use the most common SQL statement that you'll probably run into, which is the select statement. So let me talk through that really quickly. So a select statement is how you get a row or a set of rows out of a database table or a set of tables. And the way you do that is by selecting or issuing a select statement which is composed of select keyword and then a list of columns from keyword and then a table name or a list of table names, and then optionally inside brackets, I use brackets to mean optional, optionally a where statement which allows you to make statements about how you want certain things to be. So in this example select statement here, I just have a select star, which is a special sort of a keyword type, I guess, or an operator maybe. I don't know, I guess what the technical term there, but it's a way to say just select everything. So select everything from tasks, so that will select all columns from tasks. But what I could add there is say select everything from tasks where complete equals true. And then that will only select the completed tasks, or where complete equals false, and that will get all the tasks that are not complete. So that's a pretty simple statement. It's the one that you probably use the most inside of SQL. Okay, so let's get into some code. What we're going to do is go through these steps. We're going to create a SQLite Open Helper to manage the database, or help us manage the database. Then we will implement the onCreate callback inside that helper, and that's where we will create the task table. And then inside the Task Manager applications on create, callback is where we will populate the array list that we already use to hold all the tasks that we have. So I'm going to switch over to Eclipse. And we'll get started. Okay, so the first step is to create the SQLite Open Helper. I'm going to put this in the tasks package because this will be, we only have one table in our application, but I could have multiple tables, but and then I would organize things just like I'm doing right now around the objects that go in that sort of a setup. Oops, I don't want to create a file, sorry. Let me step back here. So I'm going to create the SQLite Open Helper in the tasks package by right-clicking the package, going to New, going to Class, and I will call this the Tasks SQLite Open Helper. Superclass is SQLite Open Helper, which is in the Android's database SQLite package. And then when I click Finish, I think it will create a few methods for me. Okay, there we go. Let me show line numbers here. Okay, so we're extending the SQLite Open Helper, and since we've generated this class from Eclipse, it will give us a couple different of the methods that are, since this is an abstract class, SQLite Open Helper is abstract, there are two methods that we need to implement, which is on create and on upgrade. And then it looks like Eclipse has a complaint about something. Let's figure out what that is. So it doesn't like not having a constructor. So as I hover over this problem here, underlined in red.
Yes, actually, Tony, I was going to remind you to make your font bigger. So you forget everything.
Sorry. Yeah, I guess one of the things that I did to try to make my SDK work is change workspaces, which didn't actually help, but it did change my font. So here we go. Text font, edit, 18. Okay. All right. Now can people see?
Yes, that looks a lot better.
All right, cool. Good. Sorry about that. Okay, so since there is not a no arguments helper, or I'm sorry, no argument constructor, we need to add our own constructor. So I hover over here, and I can click this little quick help guy, and this will create a constructor for us. So here's the arguments that it takes. The constructor for SQLite Open Helper takes a context, and it takes the name, which is the name of the database, and a cursor factory, which we're not going to use here. That's more for a more advanced implementation. And then it takes a version. So those kind of go back to the things that I talked about in the slides. But what I'm going to do here is just get rid of all of these arguments, because my SQLite Open Helper will not need to know about these things. I will contain those all inside of the call to super instead. So the name is going to be the name of the database, like I said, and let's just keep that inside of a constant. So I'm going to paste in a constant here. This is a nice way to manage when you have to keep strings inside of Java, to manage kind of making sure that the strings don't change all over the place. Instead, we use this constant, public static final string db name, and that's what we'll use to name the database, and we'll pass that up to the super constructor, so that will be the name of the tasks database locally. The next thing it wants to know is what is my cursor factory, which is again is more of an advanced thing, and I don't really need one here. I can allow it to create its own. And then the last argument is version. So I'm going to create a public static final int constant here, and we'll say that the version is 1. So now that when I pass this up to the super constructor, inside of here, all I have to do in later implementations, if I ever change the database, the structure of the database, then I'll just come here and I will say that the version is 2, and the next time this SQLite Open Helper runs, it will know that the version number has changed from what it knows about the local database. And then in that case, it will run the on upgrade callback. But if the version number is 1, or if the version number has not changed, or the database does not exist, then it knows it's starting from scratch, and then it will call on create. So what we want to do on create, let me get rid of this extra comment stuff here. So what we want to do on create is create the table. So let's say drop and create. Actually, that's completely unnecessary. I've got that in my code. Yeah, I'm just not going to worry about that. I'm going to say create tables instead. So I'm going to call this method create table and pass in the instance of the database. And then that method doesn't exist, so I'm actually going to paste that in here, and then we'll have a look at what we do. Okay, so hopefully everybody's following along. The first time we use the SQLite Open Helper, the database file will not exist, and it will call on create, and then we will call over to our little helper method here, create table, which I pasted in as create tables. So if I delete this, then it will find that, and then we're expecting an argument of SQLite database. And so the way that I execute any arbitrary SQL against this database is by calling exec SQL or execute SQL on that database instance. And what we're going to do here is use that create table syntax, or the create table statement, to create a table. And what I want to do also is, since I'm going to be referring to the name of this table throughout this SQLite Open Helper and possibly one other class, I want to make sure that nobody messes up the name of the table. I want that to be a constant as well. So I'm going to hover over here in Eclipse and say create constant tasks table. But I don't want it to be, well, so this little red box here means it's going to be private. That's fine. I'll just go up and fix that. So when I click this, it will create a constant, and then you can see in Eclipse that it's the constant that I just created is no longer a problem, and it's surrounded by a box. And what I can do is tab out of that, and it will tab up to the code that it just generated. So I hit tab, and then I'm up here at the top, and I can make choices about some of the optional things that Eclipse generated for me. So I don't want this to be a private static variable. I want this to be a public variable. And string is fine. Tasks table is the name that I want. Then I can tab in here at the end and make this a string. And I'll call this tasks, because the table will just be tasks. And then now you can see everything is still surrounded by a box, and I can hit tab, and it will tab me back down to where I started off. So you can see that I also need to do this for these other guys. Again, I'm creating these as constants so that everything reverts to these variables, and then I don't have to worry about anybody getting the string names wrong. So I'm going to paste in code at the top that will create these other constants. So these correspond to the task ID column, the task name column, and the task complete column. And now this create statement should look as we expect it to. So once this translates into a string, which it will inside of here, once we've interpolated these variables, then it will be create table tasks followed by a paren, and then the task ID, which is going to be ID, which is an integer primary key auto increment, not null, and then task name, which will be name, and task complete, which will be complete. And now we will have, after this create table runs for the first time, a table to store tasks in with that structure. And you can see there's one warning up here. I think that's because that cursor factory got imported. I'm just going to get rid of that so everything is running clean, no warnings. And now we have the first iteration of our SQLite Open Helper. And again, this onUpgrade is going to be called whenever anything changes, but right now this is currently unused. And we'll be making use of that in later classes. All right, so now we've gotten one step out of the way, and that's to create this open helper. Now let's look at how we will use the open helper. And that will be inside of the Task Manager application. The first thing that we need to do is to load the tasks when the Task Manager application starts up. So I'm going to open that by opening a class, or opening a type in Eclipse, which is Command-Shift in Mac, and I think Option-Shift in Windows, T for type, open type, and that will open any Java classes by the name of their class or the name of their type. And so we want Task Manager application. I could go down and that will open up our Task Manager application. Okay, so everybody remembers what this is, right? Ask a question if you don't, but this is the application that runs and stands in for our application, and there is one instance of it, and every activity can get an instance of it. And so this is kind of like the way that we'll encapsulate any creating tasks, so that and this will help. This is kind of where we're doing our refactoring. Sorry. So when I say add task, or when I say get to current tasks or something else from some other piece of code, I don't really care from that code whether that's coming out of an in-memory array or whether that's coming out of an in-memory array that was constructed from a database table at some point in time. So that's a good encapsulation. That's a good practice to keep parts of your code from knowing about the implementation details that other parts of your code are responsible for, so we can make changes like changing this array list of tasks to be from something that's just created the first time it's run to being populated from a database, and nobody else needs to worry about how that happened. So this is the point where we start to get everything set up, this onCreate method. So the first thing I need to do that is a change is I'm going to keep this current tasks. That's fine. This array list will work the same way it did before. And I still want to do this if the current tasks are null. I'm not sure if that check is actually needed, because onCreate, it should always be that case. Okay, so in any case, what I want to do is construct that SQLite open helper. So I can do that by tasks, SQLite open helper, hit Control space, and that will complete that for me. Helper, I need to get an instance of the SQLite open helper, so this is just a standard creation, which will take a context, and I can say this because the application is also a context, just like an activity is. And now I have a helper. And so I haven't run any of that. I didn't run onCreate. I didn't run anything special. All I need to do is instantiate the SQLite open helper, and it will go through that flowchart that I showed you before in the slides. It will go through this process just when I construct it. So that's all taken care of for me. All I need to do is instantiate that, and now after that I can get access to the newly constructed SQLite database in a variable, and I'll keep an instance of that, I'll keep a reference to that on the application. So now I can get that off of the helper. Get writable database. So I can also just get the database for reading, but in our case we also want to write to it at some point, so we will call get SQLite or get writable database, and that will give us a writable instance, something we can make inserts into. And now I have this variable that I want to create a field from, so I'll hover over here, create field database, and now I have a SQLite database field for the application. So what I want to do instead of just blindly creating this array list from scratch is I'll call a method called load tasks. Hover over here, create method. Now load tasks will do something like this. Let me paste in some code, and then we'll talk it through because there's a bit of a process to this. This is loading every row of tasks from the database and creating a new task object at runtime. Okay, so I pasted in some code here. Looks like I'm coming off the screen here. Let me minimize this so I can see everything. That should be almost everything. Oh, there's a lot more there. Okay. Let me format this for you a little bit. Okay. All right, let's talk this through. So the first thing we need to do is just what we did before, is create an array list which will hold all the tasks, just like the implementation already does. But instead of just sticking with a blank array list, we're going to iterate over all the tasks that come out of the database and create a task object and put that into the array list. So the way iterating over a list of data from the database is done is with a cursor. So you can see that's a class that Eclipse doesn't know about right now, but when I import Android database cursor, now I'll have a cursor class that I can work with. You can see that's an interface that allows random read and write access to a result set returned by a database query. So I also need to, and this is the benefit here of creating those constants. I can refer to the tasks table and the task ID and the name and the complete and all that stuff inside this string array, which is the second argument. So I can refer to those columns and that table name by the constants instead of the string values, and then I don't need to worry about those changing. So these are not, they don't know, Eclipse doesn't know where these guys are coming from, so I can fix that by saying import static, what was that? SQLite Open Helper package, which is com O'Reilly Android Task Manager tasks dot SQLite Open Helper dot star. Now I have access to all those variables locally, and those are no longer a problem. Tasks table, task ID, task name, task complete. Okay, so the arguments to this query are, first of all, what table do you want to call this query on? Task table. I want to get information out of the task table. Then, then I want to pass a string array, which is all the columns that I want to select information about. So let me format this a little bit. Oops. So that we can read a little bit better in context. The first argument, again, is table. Second argument is all the columns that we want to get out. So we want to get the ID, name, and complete from each task. And then there's a whole bunch of other stuff that we'll probably look at in later episodes. I think there's a couple more of these that are used. But basically this corresponds to, like, do you want any where statements? Do you want to order by anything? That kind of stuff. You can look at the signature for query. Well, here, let's look at it. It's here. So these basically correspond to parts of a SQL query. First argument, again, is the table. Second argument is a list of columns. Then selection. Not quite sure what that is. So here, when I hover over the doc, the help in, or I hover over a method in Eclipse, it will give me this Java doc pop-up. And if I hit F2, then I can get focus on here, and I can open this window a little bit and then read all about these arguments. So the first parameter is, let me zoom in a little bit here. First parameter is table. Second is column. Selection is a filter declaring which rows to return. Okay, so this is the where clause. This is your SQL where clause. Is this third argument. Then selection args. You can pass in arguments to get interpolated into the where clause. Then there's a group by clause, which is a advanced SQL statement thing, and then a having clause, which is an advanced SQL statement thing, and then there's an order by, which we are actually using. So let me escape and then zoom out of this, and then we'll look at the order by. So the last thing we want here is to order all the tasks by whether or not they are complete. So this will put all the complete tasks grouped together, and then we'll order by task name, so it's in alphabetical order, just because then things will be a little bit more tidy. And now, once that query executes, we will have a cursor object in this task's cursor. And a cursor is something like an iterator in Java, but it allows a few more things. One thing that we need to do the first thing is move to the first item in the cursor, and then we'll be ready to move through the cursor, which again is a way to navigate through a list of or a result set that comes back from the database. And what we want to do is first of all check if the task cursor is after last. If that is true, then there are no results returned. So once we move to first, and then if once we move to first we are after the last result, then there's no results. So we don't want to do any of this. So we just move on and close the cursor, which is what we do finally anyway. Then inside of there is a little do while loop with the bottom checking while statement, which moves us to the next item in the cursor. So we're already on the first item when we start off, so we want to have a bottom checking while loop, which will move us to the next item and return whether or not it actually made that move, and it will be false if it hits the last one in the list. So this is a way to loop through every item in the cursor, do something if we actually found an item at that point. And what we're going to do inside of here is get information out of the cursor and put it into a tasks object, which we've declared here and which we will instantiate right here because we made a constructor on our task object, if you remember last time, which took a name, which allows us to create a task and pass in a name. So the way that information is had from the cursor is to tell it what Java type you want and what position in the row that you want to get it from. And that is correspondent to the list of columns that you set up in this string array here, the second argument to the query. So at position 0 we have ID. At position 1 we have the name, and at position 2 is the Boolean, and then I'll just parse the Boolean value out of the string. That makes it that's one easy way to do it. You could also try to finagle that out of a 1 or 0 integer. And then I'll create the task and put that information into the tasks, and finally add that into the array list. So there's one thing that we need to now add as a concept to the task, which is an ID. So I'm going to create a method setID on type task, and it will create that for me inside of the task object. You can see the task definition. You can see it created that. And what I want to do inside of setID is set this.id equals ID, and that will fail because there's no such thing as this.id, so I'll hover over here and say create field ID in type task. Then I can tab up there and see what it created for me. Private int ID. What I actually want is a long instead, because, well, actually, what did I say? I said get int here, so we're expecting it to be an int. I think it may be the case that we want to start out with a long instead. Let me see if there's a get long, and that is because the SQLite will allow us. Yep, there's a get long. We'll change this to long, and then setID will need to change that as well to be a long. Okay, so the reason for that is I think the integer inside a SQLite can be bigger than an integer can be in Java. So I want to make sure that there's enough space and there's no resolution loss there when I get that ID out. Okay, so now I have an ID long, and I have a way to set ID, but I need to hover over here and say, well, I guess it doesn't give me that option to create a getter and setter, but I can go to source, and I need to create a way to get the ID back out. So I can go to source override, underneath override implement methods. I can say generate getters and setters, and choose ID, and it will create a get ID getter method for me, and put that up here at the top of the file. And now I'm going to tidy this up a little bit. Grab this guy, put it here. Now I have a way to get the ID, set the ID on a task, and when the application starts up, it will get all the information out of the database, get all the tasks, and it will put them into the array list, and this list will function as before. So if I run this, we should see everything working as expected. Okay, good. So we start out with no tasks because there was no tasks in the database. And it didn't crash, so looks like everything's working right. Okay, so that was kind of a long segment there, but let's talk through what we did really quickly. First of all, we created a SQLite Open Helper, which manages the database for us and manages versions for us. Then we created a database for our to store our tasks in with the create statement, and then we used a select statement to get data out of the database inside of the application. And we did all that in the onCreate, kicked it off from there, the Task Manager application. So, are there any questions about those steps?
Yes, we actually have a ton of questions. Somebody's asking, what does helper.getWritable database return when you were calling out to the helper?
In the Task Manager application, I'm going to where we actually call getWritable database. We put it into this variable, and this variable is of type SQLite database. So that's the SQLite database wrapper class, an instance of that guy.
That's where the database is getting created if that file does not exist, as we looked at in your flowchart.
Yeah, it's getting created somewhere in when this constructor is called, and that somewhere is, if we look inside here, I can hover over, by the way, I can put my pointer on this class, hit F3, and it will jump to that class in Eclipse, which is a nice thing. So that's all happening up here in the abstract SQLite Open Helper class. That's where it's going through that flowchart, or that decision tree, and saying, does it exist? If not, create it, and so on.
And we had somebody who asked why some of the database code is in the SQLite Open Helper and then other parts of the code are in the application, the Task Manager application. And my guess is that it's the application-specific stuff that's in the application and it's the more generic code that's in the helper.
Well, it's more like the SQLite Open Helper is responsible for managing the structure of the database, and right now I've made the responsibility of the application to get to deal with the data in the database. So that's how the responsibility breaks down right there. If this person is, as I suspect, having a little bit of a feeling sort of wary about having SQL embedded in the Java code, that's one problem that could be fixed by like an ORM or some other type of solution where we put that SQL somewhere else. I didn't want to go to that extreme length for just the small application. That's one thing that they could be feeling bad about. Another thing is the Task Manager application having SQL statements in it. It could be another problem that they have. So we could create another class which is responsible for actually interacting with the database, and then that would make the sort of the delineation or responsibility a little more clear between the application and some other class that's responsible for getting data in and out of the database. And that would be totally fine with me too. That would probably be a good change to make, but here for this class it's easier to have all the code in one place. So hopefully that's a good answer.
Okay, got it. We had a couple people ask about the version number and whether that version number is for the app version or the database version, or maybe both.
Yeah, it's basically both is a good answer. It's arbitrary. It's whatever number you want to make it. You could start off at 1,000. All that you need to do is make sure it changes. And I'm not sure if it needs to be greater than it used to be. If I would just fail on the side of safety and make it greater than it used to be, and that is just.
You make it greater if your app changes or if the database version changes?
Well, they're one and the same. You can't change the database without shipping the app. Or I mean, you can't change the database on a user's device, which is when all this matters, without shipping a new app. So yeah, it's kind of one and the same. But that version number doesn't have to correspond to anything in the manifest or anything like that. It's an arbitrary number that you should increment serially, or at least increasing the value of it.
Okay. And then we've had a couple of people ask about the import static, and one person was having a problem with the import static, and I don't remember where you did that.
It was in Task Manager application. I have these constants. Task ID is one, task name is another. They're defined on SQLite Open Helper as public variables, but also static variables. So what I can do to get all of these, basically, it was added in Java 1.5, maybe 1.6. I'm not sure about that, but I can import. Here's the statement: import static, that file, that class dot star. So it's beyond the class. You're usually importing a class, right? But so that Java knows how to call it from the class that you're in. But if I import static, the class dot star, then I will get all the static variables, static methods, and stuff. The compiler will let me do this without namespacing these constants, basically. Hopefully that makes sense. And that's sort of a later addition to Java.
A couple of people asked about the strings and why we aren't putting some of these strings into the XML.
Well, the XML is there basically for localization.
Oh, I see. Okay. So, yeah, so we don't need to worry about the table names being German. We just need to worry about the things that show up for users being... Okay, that makes total sense.
Exactly.
Yep, okay. And then one person asked about if you could go over task cursor. They were confused about exactly what the cursor is and how it works.
Sure. So luckily I'm on that code right now. The cursor is a way to iterate over or move through a result set that comes back from a query on a database. So that means, like, if I say get all tasks and there's 3 tasks, then I'll have 3 rows that come back from the database. The cursor will know how to move through that result set and let me get access to each one of the rows individually. And the way that works is there's an API that looks kind of like this. Move to first will move me to the first row, so I can start off with some data, and then I can query the cursor to get at its current position basically data that was in that row as a Java type. So I can get like long, or I can get int or whatever, get string, and then I query those positionally. So I'm getting the first position, or at position 0, I'm expecting that to be a long, and then the second position I'm expecting to be a string, and the third position I'm expecting to be a string, and those are the types, and getting them out at the right position. And the position is defined up here. When I make my query, I say here are the columns that I want, and they will come back in this same order. So then this corresponds right here. So task ID was in position 1, and then I get that out of the first position here. Task name was at position 2, and I get that out here, and so on. So I know that a single row, I can get all the information out of a certain row by position from the cursor. And then later on down here at the end of the while loop, or at the bottom of the while loop, then I say move to next, and now it's on the next row, and the whole thing happens one more time. And this will keep on happening until move to next returns false, and it returns false when it's at the end of all of the results that are brought back. Hopefully that makes sense?
It does to me. Hopefully it answered that person's question. So we have a couple of questions from the chat room that Ruth would like to ask.
Yes, at first we had a lot of questions regarding the database and accessing the same database from multiple apps. Is this possible, especially using the mechanism that we've used now? And a couple of people have asked to go through the database query call once again.
Sure. So accessing the database from more than one app, I don't think that's possible, because basically that's a file, and the file is stored in a private sort of sandboxed area for each app. I think there may be a way to get access. I don't know. There may be a way to get access if you have like a set of apps that you create and you explicitly grant permission to the file system for, but you wouldn't want to do that. I mean, although there's not really a problem with concurrent access to the database because you can only be working with one app at a time, I guess you may be doing some stuff in the background in one of the apps with the database while the user is using the same database from another app. I don't think that you'd ever want to do that. But what you really want to do, what your goal is probably to share data between apps, and then you shouldn't worry about the database, or that's kind of an implementation detail at that point. What you should do instead is implement what's called a content provider. So look that up on the docs, and you can look into that further. And then one of your applications will be a provider of a certain type of content, and then your other applications can consume that, and other applications that you didn't create can also consume that. You can make that API available to other applications, and that's, I think, what you're actually wanting to do. We're not actually going to go over a content provider in any of these classes. That's kind of it's a good thing to look into, though. This query is a select statement. So let me go look at select statement one more time. And here in the slides. So the select statement form is select a list of column names from a table name, and then there are conditions where, and then those are optional, and then there are other things you can say, like group things together based on these criteria, and then having is another phrase that you can use to help work with some aggregate functions that you can also perform, like average, like give me the average of these numbers where the average is greater than 10 or something, and that you use a having clause for that. And then at the end of all that, you can order things in a certain order, and that's both an order by statement. So I could put all these on here, but this isn't a SQL course, so I didn't go that far into SQL. But look at this format here. So we've got select, from, where, and then I didn't put it here, but we also have order by. And then look at this code, and this follows the exact sort of format here. So line 32 is saying select. Actually, I'm sorry, it's transposed one step here. So the first thing is from what table. So this is actually the from clause right here. So I can say, like, oops. And then down here, then there's a bunch of things like where would go here. I'd say where, and then I would use question marks for each one of the values that I wanted to put in the where, and I could have those interpolated from other variables from an array right here. I'm just kind of blowing over that because we're not getting too far into it, but you can always look at the docs or go to the forums. And then here would be my having clause, or my group by clause. Here is a having clause, and then the last thing is the order. So that right here is order by complete, and then name. So here's the SQL statement as I've created it in Java instead of SQL. So hopefully that makes sense.